Hello everyone. In this video, I will be going over how to create a free body diagram. Now these are very useful for whenever you have to deal with a force problem or a Newton's second law problem. And basically what it does, it just shows you all the different forces acting on an object. So we'll first start with this scenario. There is a box simply resting on a table on Earth. So to create the free body diagram, we have to show all of the forces acting on the object. The first thing we have to ask is the object on Earth? And if the object is on Earth, then we know that the gravity is going to be pulling down on that object. So we know that our box is on Earth. So to draw that force of gravity, what we do is we draw an arrow from the center of the circle, going straight down, because gravity is pulling straight down, just like that. And then we need to label it. We normally label these arrows is the capital F for force, and then we can write grav for the force of gravity. And we normally write that right next to that arrow. So that's how we would represent the force of gravity pointing straight down on that box. So the second question we have to ask is, what is the object in contact with? Well, in this scenario, we know that the box is resting on a table. And the table is actually going to push back up onto that. The table is going to push back up on that box because of the normal force. So how we would represent that is with another arrow from the center of the circle, pointing straight upwards. And how we normally label the normal force is just the capital N, the subscript of N for normal force. And we write that right next to that arrow. So this would be the free body diagram of a box simply resting on a table. Let's try something else. We can say that in this scenario, there is a ball falling straight downwards and it is experiencing air resistance. So the first question we have to ask once again is it on Earth? And we can say that yes, it is because gravity is pulling it down. So what we do is we draw the arrow for force of gravity and then we label it. So before it's F subscript grav. And then we can leave it there for now. And now we have to think about what else is the object in contact with. Well, there's no hard substance or there's no physical substance it's in contact with besides air. But we know that the problem stated that there is air resistance. So that's going to exert a force on that ball. That's going to be pointing straight upwards. So we draw from the center of the ball, the direction of the force, which is straight upwards, and then we label it as force of air resistance, or force of drag. Either way, you can write it as AR, or we can write it as the drag force. So that's going to be our free body diagram for a ball falling straight down with air resistance. So now we can move on to one a little bit more complicated example. We can say that there is a ball rolling down an incline, like rolling down a hill, a slope, anything like that. So we ask ourselves once again, is the object on Earth? And we can say yes, the ball is on Earth. So there is the force of gravity. And the force of gravity always points straight downwards, no matter if the ball is on an incline, on a even surface, anything. The force of gravity is always straight down. So we will label that as force of gravity. So now we know that the ball is rolling down an incline. So for the second question, what is the object in contact with? We know that the ball is in contact with the incline. So there will be a normal force. But what we have to keep in mind for normal force is that it always acts perpendicular to the surface. So if there is an incline like this, and the ball is rolling down, the normal force is going to be perpendicular to the surface. So the normal force is actually going to point like this. So how we can label that on our diagram is show roughly the same angle. So we're going to go back right here from the center and draw it at a roughly the same angle, like that. And that is going to be labeled as force just like that. So, and in this scenario, we're just going to say there's no air resistance, nor is there any friction. So in this scenario, gravity is going to be pulling us straight down, and the normal force is going to be pointing at roughly that angle right there. So that would be the free body diagram of an object rolling down an incline with no air resistance or friction.